This is part 3 of the area of a triangle, calculations using trigonometry for the National 5 course. What we've covered so far in part 1 was some of the basics of just using the formula and working backwards to find the angle when we know the area. For part 2 we were looking at extension questions and to a certain degree, and what we've got for part 3 here is some questions in context. I've got 2 calculator questions and 2 non-calculator questions that are at the top end of the work for the area of a triangle. Right then, let's look at the first one. So what we've got is the Pentagon building has an area of 116,000 metres squared. Okay? Calculate the distance from the centre of the Pentagon to one of its vertices. So that would be one of its corners. So that would be X in the diagram that's just down below here. Right then, so answering to 2 significant figures. So let's go ahead and solve this question here. Right then, so it's a calculator question, this one. So let's see what we have to do in this. Right then, so first thing I can see is I've got, I can make up a triangle here inside this pentagon. Just a simple drawing of it here. What I have to work out is I have to work out the size X that's there. So what that's doing is that's going from the centre of the pentagon right there, and what we're going to be doing is finding out what distance that would be if I was going to be walking that from there right out to the corner. Okay, so that's X that we're trying to work out there. Right, so a couple of things that I need to start with. So if the Pentagon building area is 116,000, what I want to do is I want to split that into the triangles that I've got, because I've got 5 triangles, so I'll divide that area by 5. So the area of the triangle is going to be equal to, and that's going to be a half AB sine C. So that's straight from the formula list that you would get. Right, so what I'm going to do is I'm going to use the area of the triangle first by working that out based on this. So dividing that by 5, so I'll go for the area of the triangle. It's going to be equal to 360, oops, I'm going to be working out the angle as well, so let's take that one away. Let's go for 116,000 and I'll divide that by 5. And what that will do is that will just give me the area of one triangle that's here. So here we go. So 116,000 divided by 5, that gives me 23200 centimetres squared. So that's the area of the triangle. So at this side here, I've got 23200. I've got half times 8, well, A is equal to X, okay? If I set my triangle up, so that's C, that will be A, that will be B. Across from here is A, so this is a side A. And I know this one here is the same as the radius of that circle, which would be X centimetres, or metres in this case. And let's see, the angle in there is the next thing I have to calculate. So the angle in here is going to be equal to the angle in the triangle. That's 360 degrees divided by 5, which gives me 72 degrees. So that's going to be 72 degrees in here. Okay, so I've got enough information to try and work out the question that I'm trying to do here. So what I've got is I've got half AB sine C times by X and times by sine of 72 degrees. Right, so what I have here is I've got X and X, so I'm going to multiply them together. That'll give me an X squared, and I'll divide by these things over on the left hand side. So let's go ahead and do that just now. So 23200 all divided by, change that to 0.5, and that'll be times by sine of 72 degrees. Remember, I've got X times X here, that gives me X squared. Right, let me calculate this part here. So I've got 23200, what we'll do is with that is 23200, divide that by 0.5 times sine of 72 degrees. And that equals, so X squared is going to be equal to 48787.8472. Okay. To work out what X is equal to, I'm going to take the square root of that number. that should give me my value for x that I'm after. So square root of the answer, that should give me 220.8797, and I have to give my answer to two significant figures, so x is going to be equal to, cut the number there, 220, 0 to show where the decimal point is, and it's going to be in metres this time, isn't it? So let me kind of change some of these things. So that's metres, and that's going to be metres. Okay, that was two significant figures. Okay, so distance from the centre of the pentagon out to one of the vertices is going to be 220 metres. Right, moving on, we're on to a non-calculator question that's here, which is, I would think, a reasonably complex one. Right then, so a regular hexagon has an area of 24 root 3 centimetres squared. Using sine 60 degrees, which is equal to root 3 over 2, calculate the length of one of the sides. Okay then. Right, again when I see this, what I'm going to do is I'm going to set up a triangle. So setting up a triangle from the bottom here, up to here, and up to here. Okay, and this part here also. This is the part I'm trying to work out. I know that it's a regular hexagon, and inside a hexagon I've got 6 triangles, all the same, all with the same angle. So I know that the angle in the triangle is going to be 60 degrees. So the angle, the way that we work that out for the triangle, is 360 divided by 6, which equals 60 degrees. Okay, so that's how I've got that. I know that all of the sides are the same because it's an equilateral triangle, so all the sides are the same size. So this is going to be x centimetres, and that's going to be x centimetres there as well. So all the sizes in the equilateral triangle are the same. All the angles are also the same as well. Right, so let's start by looking at working out the area of the triangle. Now I know the area of the hexagon, so I could say that the area of the triangle is going to be equal to the area of the hexagon divided by 6, because there's 6 triangles that are in there. Okay, so I've got 24 root 3 divided by 6, okay, which is just the same as 24 root 3 over 6, which should give me 6 into 24 will give me 4 root 3, and that's centimetres squared. Right, so from there, what we're going to be looking at is we're going to be trying to work out the area of the triangle using the formula for the area of the triangle, and working out the size of the sides. So the area of the triangle, formula, from your formula list, half AB sine C. Let's label triangle up in that way. So I'm going to call this C here, call this A, call this B. Across from A is small a, across from B, small b, and across from C, small c. Don't really need the C. Let's put the values that we have in. So what we worked out was the area of a triangle is 4 root 3, and we've got half, and that's going to be times A, and A is x and B is x as well. So it's going to be x times the sine of 60 degrees. We've been given in the question sine 60 is equal to root 3 over 2. So let's substitute that in. So 4 root 3 is equal to a half, and I'm just going to put that in as x squared, the x times the x, and I've got root 3 over 2. Okay, so what I'm going to do is I'm going to change the subject of the formula around to x squared by taking things over to the left hand side here. Okay, so what I could do first of all is I'll multiply this part out so I've got it on the right hand side to try and make it a bit easier for you. So I've got 1 times root 3, so that's going to be root 3 on the top, x squared, on the bottom 2 times 2 gives me 4. what I'll do is I'm going to try and change the subject. So if I'm dividing by 4 on this side, I'm going to multiply by 4 over that side. So that's going to be 4 times 4 root 3. And because I'm timesing on this side by root 3, I'll divide on this side by it. And that equals x squared. Now multiplying this out will give me 16 root 3 all over root 3, which equals x squared. Being a non-calculator question, what we can do is we can divide the top and bottom by root 3, and what that'll do is it'll cancel these ones out here. So what I know from here, I've got x squared is equal to 16. So the value of x, square root of 16, x equals 4, working in centimetres, 4 centimetres. And that would be that concluded. Again, tough question. You should already have the skills to use surds. Using surds, the changing of the subject of the formula, knowing how to work out the angles in a polygon, and using the area of a triangle formula. So they're all the things that you've learned throughout your National 5 course so far. Right, 2 more questions to go, and that'll be that concluded for now. Right, so what we have here is we have a stop sign. Stop sign is the shape of a regular octagon. Okay, so an 8-sided shape. The diagram shows 10 centimetres as the length of the radius of a circle that the octagon has been drawn inside. So we can see it here, okay? Another one of these, we've been given that sine 45 degrees is 1 over root 2, and show that the area of the stop sign is 200 root 2 centimetres square. So we get an exact value that's coming in there. Right, let's see how we would go about this. And it's quite similar to what we've done before. I'm going to try to look for a triangle in here. And what we'll go for is, I'll go for this one here. So there's plenty of them. Okay, there we are. There's a triangle. And it's an octagon. So I've got 8 of these triangles in here. What I'll do is I'll label this up as C, this up as B, A, sorry, and this one up as B. If I know that's 10 centimetres there, then this part here must also be 10 centimetres because it's the radius of the circle. The angle in between, well, in the diagram I've got, I can just see it and know more, but if I don't know that, I can work out the angle in the triangle. So the angle of the triangle is equal to 360 degrees divided by 8, because I've got 8 triangles that are in here, all the same size. That's going to give me 45 degrees. Okay, that matches up well with what we've been given as well, so that's okay, that's there. Okay, so that's 45 degrees in here, 45 degrees. Right, so opposite the side A, the angle would be A. Opposite the angle B is B, and opposite C is the small c, and we won't need that one. Right, so let's see. So we have to work out what the area is, and we've got the answer there, so hopefully that we can work it through and calculate that out. So let's work out the area of the triangle first, and that's going to be equal to half AB sine C from our formula list. So it's going to be a half times A, which is 10, B, which is 10, times C, and C, sine C is going to be the sine of 45. 45 degrees. Right, so let's substitute some values in, and what I'll do is I'll calculate this part here as well. So that's going to be a half of 10 is 5, 5 times 10 is 50, so I've got 50 here, times, and for sine 45, what we're doing is we're going to substitute this exact value here in. So I've been given that, and that's how it allows us to do this as a non-calculator question. So that's going to be 1 all over root 2. Okay? And if I multiply that across the way, I've got 50 all over root 2 as the answer for the area of the triangle. Right, so it's an octagon, so I need to multiply the triangle size for area by 8. Okay, so let's do that. So the area of the octagon is going to be equal to the area of the triangle. And then times in that by 8. So let's go for 50 all over root 2 multiplied by 8, and that's going to give me 400 over root 2. Okay, so as we got an answer, let's see if it's the same. Well, it's not the same as that one there, right? So what I've got to do is, I don't see any roots on the bottom there. I've got a root on the bottom. So from my knowledge of surds, I could rationalise the denominator by multiplying the top and the bottom by root 2. Okay, so rationalise the denominator. So what we'll do for that is I'll multiply it by root 2 on the top and by root 2 on the bottom. So root 2 over root 2 is just 1, so I'm not really changing it, but I'll change the way it actually looks. Okay, so what I've got here is I'll have 400, and that will be root 2 all over root 2 times root 2, which will be root 4, or what I would know is that root 4 is 2, okay? Or root 2 times root 2 is just straight 2. I'll then divide 400 by 2, and that should give me 200 root 2 centimetres squared, and that's the answer that I have to show. So that's it as required. Okay, and there's my final answer there. Okay, so complex question, working with surds already up here, rationalising the denominator, making sure that you know how to do that, and knowing the properties of an octagon. So quite a complex question, this one here. Last question we're going to go to, and we'll make that a calculator question for this one here. So this watch face is in the shape of a regular decagon, so it's a 10-sided polygon. The diagram below shows 5 centimetres as the length across the face of the watch. Calculate the area of glass that's needed to cover the watch face. Answer to 3 significant figures. Okay then, right though, so with these types of questions, just going to be looking at the same type of thing. I'm going to be trying to work out to get a triangle. So what I could see a triangle being from the centre out to here. So it's quite a slim triangle here. I'll just cover it in red so we can see the difference between that and the other line. There we go, there to there, and what we've got is here. Okay, so there's a triangle. From this triangle, because right across, or if I drew a circle, that would be the diameter of the circle would be 5 centimetres. So I know that this side of the triangle is 2.5 centimetres. 2.5 centimetres for this one also. Okay. What I need to work out is the angle that's inside here. So the angle of the triangle is going to be equal to 360 divided by how many sides the shape has. Being a regular decagon, it's going to be 10. So that's giving me an angle of 36 degrees inside here. So that's 36 degrees in there. So to work out the area of this triangle, I need the 2 sides and the angle in between, and I've got that, so I'm going to go ahead and work that one through. So the area of the triangle is going to be equal to, from the formula list, a half AB sine C. Right, let's go for this one being C, this one being A, this one being B. Opposite the angle A, it's going to be A, opposite the angle B will be B, and C is the one that's out here. Substitute our values in, okay? So a half times 2.5 times 2.5 for B times sine of the angle 36 degrees. That should give us straight into the calculator. So what we'll get for that is, let's go for 0.5 times 2.5 times 2.5 times sine of 36 degrees, and that should give us 1.8368, and we've got plenty of characters there, so that's going to be in centimetres squared. and it's the area of the glass, or the area of the watch face that I'm interested in, to 3 significant figures. So the area of the decagon, which is the watch face, is going to be equal to the area of the triangle and I'll multiply that by, and I've got 10 different triangles, or 10 congruent triangles that are in there, okay? So multiply that by 10, just leave it in the calculator, and that should give us 18.368289, okay? And I'm going to answer this one to 3 significant figures. So cutting the number here, okay, so that's going to give me 18.6 is going to round to 3 up to a 4. That's going to be centimetres squared, and that will be 3 significant figures for this question here. So 18.4 centimetres squared. Okay, so that's part 3 completed. It's given you the basics of a triangle in part 1, working backwards with the area just in simple triangles. In part 2, some of the more complex work, so the extension type of work, and here some further complex work. Remember to look at the non-calculator questions, because these ones here could feature in your National 5 non-calculator exam paper. So good luck, and all the best with the area of a triangle.